Hello, sir. Yes, sir. How, sir? Sir. Good morning. A warm welcome for 5-day online faculty development program on sustainability solutions in hybrid electric vehicles, organized by the Department of Mechanical Engineering, Mangalore Institute of Technology and Engineering, Modibidre, Karnataka. This faculty development program is sponsored by IITD, New Delhi. On behalf of the program organizing committee and Mangalore Institute of Technology and Engineering, I, Professor Rajashekar, Vice Principal and the coordinator of the program, would like to thank IITD, New Delhi for sponsoring. Who can be an asset to any organization. Located among lush greenery and a peaceful ambience in Modbidri, the campus spread over an area of 74 acres, integrating modern design, construction technology, and eco-friendly techniques. The campus provides the right setting to the students for effective learning. MITE is affiliated to Vishwesvaraya Technological University, Belagavi, and approved by IICTE, New Delhi. The Department of Mechanical Engineering is one of the pioneer departments in MITE. The main objective of Bosch Electronics Automation Center. In the 21st century, hybrid electric vehicles have surged due to a depletion of fossil fuels and transportation's impact on climate change. The study estimates a cumulative investment need over $180 billion, that is approximately about 12,50,000 crore in vehicle production and charging infrastructure until 2030 to meet India's electric vehicle ambition. India gigawatt-hour by financial year 2030. An investment of over 180 billion in vehicle production and charging infrastructure needed. cumulative electric vehicle sales to cross over 100 million by financial year 2030 from just right now it is about 0.5%. As a result, the study says cumulative electric vehicle sales in all vehicle segments would jump to over 100 million units by financial year 2030. That is 200 times its current market size of just 500,000 as of March 2020. Availability, affordability, and capital for original equipment manufacturers, battery manufacturers, charge point operators, and end consumers would be the key determining the pace, the efficiency, and the cost of India's transition to electric vehicles. The study estimates that realizing the ambition would require an estimated annual battery capacity of 158 gigawatt hour by 2030, which provides a massive market opportunity for domestic manufacturers. Even if 50% of battery manufacturing capacity were indigenous, investment would amount as much as 6.1 billion by financial year 30. Further, cumulative investment required would exceed 12.3 billion in case of 100% indigenous battery manufacturing. The recently approved production-linked scheme for the automobile and battery manufacture sectors could help enable right ecosystem for indigenous and job creation in electric vehicle sector. Another big opportunity would be in the area of charging infrastructure. India would need a network of over 2.9 million public charging points by the financial year 2030, beyond in-home charging points. In addition, it recommends development of policies around battery reuse, recycling, and leasing to help bring down high upfront cost of electric vehicles. To encourage uptake electric vehicles, it calls for creating state electric vehicle policies which combine incentives for electric vehicles with disincentives for internal combustion vehicles. So in this regard, we, Mangalore Institute of Technology and Engineering, under the sponsorship of IITD, are organizing a faculty development program on sustainable solutions in hybrid electric vehicles with the following sessions: an overview of electric vehicles and hybrid electric vehicles, importance, challenges, and emerging technologies in hybrid electric vehicles, policies and standards in electric vehicles and hybrid electric vehicles, electric machines and selection of motor and controllers for electric vehicles, simulating vehicle setup on MATLAB, component sizing and integration, fundamentals of battery pack mechanical design and thermal design, thermal management in electric vehicles, lightweight of electric vehicles using MDO, electric vehicles charging infrastructure. These are the various sessions we are going to cover in the coming 5 days. About 11 sessions will be delivered by industry professionals. On behalf of the organizing committee, I welcome all the participants, resource persons, our beloved principal, Dr. G. Alisha Prasad, deans and HODs of MITE for the program. Dear participants, please attend all the sessions. As per IITD norms, a test will be conducted on the last day of this program, that is on 17th of December. It will be MCQ test based on contents covered in each session. Participants, please note that a minimum of 60% of marks to be scored and to get the e-certificate. With this, I welcome you all. Now, I request our principal, Dr. G. Alisha Prasad, to address the participants. Sir, over to you.
Dr. C.R. Rajashekar, good morning, and respected audience, my dear faculty members. Once again, good morning to all of you. It's my pleasure to be associated with the inauguration of this such an important technology-oriented program, and I'm really happy to know and bring it to the kind consideration for all the participants and everyone here. Our mechanical engineering department is continuously conducting the faculty development programs. In this academic year, it is the third in series, and particularly the topic is of high importance. We know the available natural resources when it is reducing these electric vehicles is the study on the electric vehicles and its impact on the society is of high immense value, and definitely these things have to be worked out, and we know how the technology development has supported everyone around the world in learning in many ways. In the same way, the development of technology on the electric vehicles definitely will have a very high future, and is a very good topic. And series of lectures have been organized on these particular topics. It's my sincere request to all the participants is that one must show an effective participation in learning. Getting an opportunity to learn is a great chance. Getting an opportunity to learn is a great chance, and such an opportunity we have to encash and carefully do it. Day old, we used to search, are there any FDPs conducted around so that we can get a chance? But these days, when we are getting such good opportunities, we must make the best use of it. It's my pleasure to be associated with all of you in this particular opening. And furthermore, my wish is all the participants must make the best utilization of the time and make the sessions as highly interactive, sending your request through messages so that all such queries will be answered by the respected speakers. And I wish you all an excellent learning, an excellent program, and an excellent outcome of the program. I wish you all a great day and a good luck and good success in this program. Thank you all.
Thank you, sir. Now I request my colleague, Mr. Swaroop, to invite today's keynote speaker to the program and introduce him to the participants. Over to Swaroop.
So thank you, sir. Good morning, everyone. So myself, Swaroop, Assistant Professor, Department of Mechanical Engineering from Mangalore Institute of Technology and Engineering. So dear participants, so before we start this session, I would like to brief out sessions for today. So morning session will be from 10 a.m. to 11:15 a.m. an overview of electric vehicle and HEV. Next session will be from 11:30 to 12:45, importance, challenges, and recent technologies in HEV. Third session will be from 2 o'clock to 3:15. That is on codes and standards for HEV. So we shall start the first session of the program today. So the title, an overview of EV and HEV, by speaker Dr. Bhim Singh, Professor, IIT Delhi. So I would like privilege to give introduction about our speaker. So Professor Bhim Singh has received his BE Electrical from the University of Roorkee, India in 1977, and his MTech Power Apparatus and Systems and PhD from IIT Delhi, India in 1979 and 1983 respectively. In 1983, he joined the Department of Electrical Engineering, University of Roorkee. So now it is IIT Roorkee as a lecturer. He became a reader there in 1988. So in December 1990, he joined the Department of Electrical Engineering, IIT Delhi, as an assistant professor. He has become an assistant associate professor in 1994 and a professor in 1997. He has been ABB chair professor from September 2007 to 2012. He has also been CEA chair professor from October 2012 to September 2017. He has been head of the Department of Electrical Engineering at IIT Delhi from July 2014 to August 2016. He has been the Dean Academics of IIT Delhi from August 2016 to August 2019. He is J.C. Bose Fellow of DST, Government of India, since December 2015. Professor Singh is the chairman of BOG, Maulana Azad National Institute of Technology, Bhopal, since 3rd July 2018 for 3 years, and non-official independent director, NTPC Limited, since that 17th July 2018 for 3 years. He is a CEA professor since 2019. Professor Singh is also a member of Governing Council of Central Power Research Institute. Professor Singh has guided 92 PhD dissertations and 168 ME MTech theses. He has been filed 63 patents. He has executed more than 80 sponsored and consultancy projects. He has co-authored a textbook on power quality, that is, power quality problems and mitigation techniques, published by John Valley and Sons Limited in 2015. His areas of interest include solar PV grid interface systems, microgrids, power quality monitoring and mitigation, power solar PV water pumping systems, improved power quality AC-DC converters, power electronics, electrical machines, drives, flexible alternating transmission systems, and high voltage direct current systems. With this brief introduction, I would like to invite Dr. Bhim Singh, Professor IIT, to give a talk on this session. Over to you, sir.
Good morning to all of you. And I think we have to say.
Good morning, sir.
Good morning, Dr. Sahab. How are you?
I'm very fine, sir.
Yeah, I think now. And that is it. Okay. I hope you can see the slide.
Yes, sir. It is visible.
Okay. Thank you. Good morning to all of you. And first, I would like to thank to the organizer. I mean, especially very, you can call it the very long friend. Who has been probably with us for a long time, and I think still we have a contact. So really, it is a good remembrance after a long time. And of course, I hope this FDP program from mechanical side.
Yes,
Okay?
sir.
But I am from good morning. It is from electrical. I am from electrical. So let us say how typically goes hand to hand together. But well, I have delivered the lecture on EV in many other places also, and especially one of the mechanical forum, especially the department and the institute typically, and they were scared that okay, we are going to trap probably a entire mechanical. No, it is only what we are going to give you in this either hybrid vehicle or electric vehicle, a efficient energy conversion from chemical to mechanical. Your battery is also chemical. And of course, wheel is already mechanical. Maybe earlier you were using the chemical energy in terms of your petrol or diesel or CNG, but that is get replaced by the battery, and we are converting well to again mechanical. But only the difference is that you might have an engine earlier, internal combustion engine, which have a 30 to 40% efficiency. Here we are probably able to come about 90 to 95 to 96% efficiency of this electric motor, which is used in this electric vehicle. That's the only change. Remaining things are yours. Okay, we are able to remove the gear also and match the characteristic of the vehicle reasonably good extent. Okay, with the typically with the motor characteristic with power control. So that really reduces. One is the fuel reduction because of the efficiency increase to almost double, around 96%, maybe around 45 or 40% to 95 or 96% of electric motor. And another major reason is that we are able to get around 40 to 50% regeneration, depending upon where we are driving this vehicle. Also, so that may hello.
Yes, sir. Please continue,
Okay,
sir.
that is okay. I'll just have a lecture. I will call you. Okay, so sorry. So what typically, you can call it if we have a 40 to 50% regeneration, the fuel cost further will go down. And whatever you are applying the brake in internal combustion engine based vehicle, it goes all dust particle, small particle, which really hampered your health. But here we recover the energy back to the battery. And depending upon the city like Delhi, we can have even the regeneration about 40 to 50%. And because of this, the fuel cost goes down. I mean, even in Delhi, the vehicle, the government have procured some of the vehicle for government officers. They evaluated 89 paisa per kilometer at the moment, where petrol is already 5 rupee per kilometer. So it's a drastic reduction in the fuel prices, about 1/6 to 1/7. And this is only when we are getting electricity at the 10 rupee 25 paisa. But tomorrow, look, you can think about the renewable energy. We cannot convert the renewable energy into oil or the gas, but we can certainly convert into electrical and charge the battery very low rate. And the last quote, of course, in India also of solar energy, which we really convert into electrical and we can charge the battery of vehicle, it is already 2 rupee per unit. But I was just probably one of my friend from US, he sent the clip that in Abu Dhabi, it has gone already 1 rupee per unit. So when your cost of electricity is going to down 2 rupee, 1 rupee per unit, maybe we'll get 2 rupee per unit in place of 10 rupee per unit today. So maybe electricity cost will go down 1/5 further. That 89 paisa or 90 paisa may go probably around less than 20 or 25 paisa. So you'll be able to run your car around 25 paisa per kilometer in place of 5 rupee per kilometer today. So you can think about what the revolution going to come in next 4 to 5 years, when our federal government have decided by 2030 we should convert all vehicle into electric vehicle. So just to give you just idea why we should go in this direction, and why this your FDP is also very, very relevant in the sense to the people, that we should go probably get people aware and make them to learn what is really this your electric vehicle or hybrid vehicle are there. Like, I mean, so with this, I mean, I would like to probably go ahead with the slide. As far as this electric vehicle or hybrid vehicle have been a offshoot in between of electric vehicle. And I will tell you why it has been the offshoot of, I mean, like, so history started from 1828, and which was first small electrical car. Then it came first crude electric vehicle in 1832. Then 1889, first electric vehicle debuted in US. Then in 1899, electric car gained popularity, and 1900 electric car reached their headway. And Edison takes the electric vehicle batteries in 1900, and then first hybrid electric car is invented in 1991. And 1998, I mean, typically the Model T deals to electric vehicle, and 1935 decline electric vehicle. And the major reason have been the battery, I mean, like the distance and all that. And 1968, of course, gas prices again soar after, you can think about, like 35 to around 73, around typically around 40-50 years later. And once it soared, then people start again going to be with the electric vehicle. And next generation electric vehicle came in 1973. Then it go and lead typically the sales, and then interest in electric car fades again. And new regulation of new electric vehicle came in 92, and typically the GM launch, I mean, in 96. But again, there was a problem. I mean, they have to withdraw, and then we have the technology which got developed. Now I can tell you, it never go to waste. So there was a main concern of this GM EV1, which was put in California. Only the range, the battery, like typically. And you can say the time for developing, I mean, developing the technology, there is some different time, but launching the technology, there is some different time. So the reason being, technology was already there, so people start looking how to extend the range, and they came with the concept of hybrid. And hybrid, you take all the benefit, virtually you can call it of electric vehicle also, but since you have a engine there, the capacity of engine, you can understand, we call it like in a, probably you might be knowing more about the vehicle. I'm not really a mechanical person, so the main rating, I mean, like, is because of the brake horsepower, which you require during dynamics. Okay, you have to keep a very large rating. But if you can call it 50%, your engine can give, 50% motor can give, then your engine of 50% is more than enough the vehicle in the finally on the road on high speed. So during dynamics, like, you can take a help of this electric motor by having a 50% torque and the rating of the engine, and that half rating is more than enough to not only run the vehicle at final speed, but also to charge typically the battery through the same motor working as a generator. Like, so this hybrid vehicle came in 1997, and I have seen in North America from year 2000 or 99. I mean, it really rule up to now. I mean, in Singapore now, hybrid vehicle is really a great. So last 20 years is the time of your hybrid vehicle. But I can tell you, like now, it's already typically a time has come for, you can call it like available in sale in 2000, not only 2010. I have seen already in year 2002 when I am going to Canada even every year from last 95 to now. So around 2000, I have seen many hybrid car in North America, especially Canada and US, and it has seen up to now, and still it is there on the road. But now electric vehicle start coming after the Tesla start putting the electric vehicle, because that was the main hurdle by the battery. And now battery they are able to get it, okay, we can go around 500 kilometer or so. So certainly you can call it like a, this is the right time when we are going to come into plug-in electric vehicle. And you can understand in Indian road we have around 3 crore electric vehicle, commercial electric vehicle. I mean, typically people call it like a, I'll just tell some light at the end of this, like a kind e-rickshaw, which is a good model for employment of the people around of 3 crore people. If 3 crore e-rickshaw are there, 3 crore unemployed, uneducated people got the employment. They are not literate, they are not educated, they don't need the license, but they got the opportunity to drive this electric vehicle, light electric vehicle, which you call it e-rickshaw or three-wheelers like also. So time has come, like we have to probably, the federal government have decided, and this was not the model from the government. It's only government has facilitated to allow them to fly on the road. I mean, typically, otherwise you can call it like it is a, the people really gave a revolution, because it's a such economical model. People can probably, the person who was earning around 200, 250 rupees as a daily wages, he's able to earn 500 to 600 rupees every day by driving this your e-rickshaw. So this has given a great revolution. About like a typically at the moment might be 3 crore e-rickshaw, but I am projecting next 5-6 years it may become around like 8 to 10 crore. I mean, like this, I'm not talking about like other than three-wheeler, light three-wheeler form of e-rickshaw for passenger, but it has start coming for other application also, because it's a kind of a light commercial electric vehicle like also. So why electric vehicle? I mentioned already, the one of the major reason is that the oil which we have at the moment, the 50%, 49.87% are consumed on road in the vehicles. So you can understand, I mean, 50% when you are consuming, probably today we have a reasonable, and if it is going to increase in the same manner, then certainly from where the, this is the slide which gave. At the moment we are probably, I mean, somehow we are managing that we are able to have enough oil, I mean, for this worldwide. This is the demand going to increase of world oil demand. I mean, and you can call it 50% is supposed to be in the vehicle, and the production is going to down. I mean, like, so if production is going to be, let us say, in by 2050 going to be half what we have today of oil production, but the requirement is going to be double, then how to this gap have to match? It is only that you can think about running the vehicle like electric vehicle, which is, let's say, get energy not from oil or the gasoline or conventional fossil fuel, but it get the energy from something else. And one of the, certainly the great is the renewable energy like solar and wind, or many other like a hydro, or so many from which we can produce the electricity and can run the electric vehicle or the wheel on the road, like, I mean, also. So this is typically the example, like why we, the one, another reason is the typically the pollution, carbon dioxide pollution. Another is the your environment or temperature increase. Okay, over the 40 years, it has already increased around 1 degree Celsius, the global temperature. So, and these are the kind of, you can call it your ignition engines, which are IC engines, which produces the this kind of the pollution, I mean, like, and harm the environment. And of course, we have a, you can call it panel on the climate change in 2007, where the all the country agreed to really typically limit this temperature rise and reduce the pollution. So that was Paris Agreement of 2015 also, to limit the temperature rise not to go more than 2 degree, or to keep it in that reduce the pollution. I mean, like, so another, of course, is the major reason is the advances in renewable energy, as the cost is going to reduce it, and government of India already plan it earlier 175 gigawatt 2020, but now they have increased to 2022 by increasing not to 175 gigawatt but to 225 gigawatt of renewable, like, I mean, also. So, well, and other advantage, that is of course the what I told you, the pollution and the energy which you may get from other sources like renewable. The another advantage I already talk about, that energy efficiency. I mean, this all electric vehicle use the typically the energy, because some energy you recover it from regeneration in this, which you cannot recover in case of your typically IC based vehicle. internal combustion based, but here you can recover the energy depending upon the highway. Even a highway you can recover around 15 to 20%, but in city driving where you have a lot of traffic, you can easily recover 40 to 50%. Like I can give you an example. Even in Delhi, you might have a metro. The last tender, last fourth phase of the metro is they got it because they claim it 40% regeneration. And you can understand the metro stops only on fee station, which are well marked. But here, when you are driving a vehicle car, like in Delhi, it's not a traffic light only where you stop. You have to slow down your vehicle, apply the brake. I mean, because you have a lot of traffic congestion also. So because of that, also you will be applying the brake in city driving many time also. So there are more chances of you can call it the regeneration. I mean, in a city driving also. Like so, these are the some of the problem you can call it with the internal combustion engine based vehicle. So here you are able to, let's say, get a, these will not be there in case of electric vehicle, and these are the kind of electric vehicle starting from two-wheeler, then another kind of two-wheeler which is little craze for teenagers, and even the most of the manufacturer, or let's say the investors, they are finding a very big scope in the two-wheelers. But this is the vehicle of India at the moment, which I was saying around 3 crore vehicles are on the road, apart from of course the four-wheeler, like I mean coming up like also. So here you can call it no emission. I mean, the carbon footprint reduces because you can use the renewable energy for charging, and petrol and diesel may not be needed maybe after some time. Another is that this is another reason that it is cheaper. It will become a cheaper one, at least 1/3 cheaper or 1/5 cheaper. But and another is you get efficient conversion compared to this, like almost double efficient also, which I already mentioned it. And now Tesla electric car, you might have seen the 300 miles around 500 kilometers, but Volkswagen have already promised 400 miles per charge. So it means you can go easily 500, 600 kilometers on single charge. I don't think you drive the car in India more than 400 kilometers in any way or so. So certainly it serves the purpose for many purpose. There have been an innovation in charging technology also, that you know, to look, you go to petrol pump, you never fill most of the time your car with the full petrol. You just ask for only 300 rupees petrol. Like so, here also the charger will be of this nature that you can get charged for 3 minutes and you get enough charging for 300 kilometers. Not necessary to fully charge your battery. But in the night when you are really parking your car, you can fully charge again for next day, like also. So these typically the another, of course, the about the health benefit. I mean, because you have a less pollution by this and less vibration and less emission, like so good for health. Another is that here very important is, of course, you have a less moving parts here than the conventional one, because you use the electric motors. So traditional combustion engine have a hundreds of moving parts, whereas electric motor has only fewer than 20 parts. So number of the parts, you can call it moving parts, will be reduced to 1/5 or so in kind of electric vehicle also, and certainly the maintenance cost also will reduce in these vehicles. Like the another major revolution is coming like a smart grid structure, because we are charging these all the vehicle from the grid. So we have to make the help the grid also. So your charger, which are coming, the latest charger, they can provide the ancillary services to the grid. Not only typically like a only that you can have a we call it V2G, vehicle to grid power feed. I mean, and it's something like that. You can call it like in a smart grid structure. We call it. You should be able to run car. You are almost with free of cost, because of the another reason that when you have a renewable integration, you will have a intermittent power coming on the grid. So sometimes the prices of the electricity will be high, sometimes prices will be low. So when you have a prices of the low of electricity, you can charge your battery of vehicle, and when prices are high, part of your energy which you stored in your vehicle battery, you can sell off back. So that is something like the difference. You will be able to run your car, but the major benefit to the grid that you are stabilizing the grid. I mean, typically. Apart from that, you have a converter in that which can give you a reactive power support also on the demand, because you may not be giving too much active power, but certainly you can sell off reactive power, as well as you can take care of typically of your load balancing also. The other aspect of your charger can provide, because charger you already invested a good charger, have a good converter which can give a many support to the grid, like a reactive power support, harmonic support, I mean, balancing support, compensation support, other than active power, like also. Another is center of gravity is also better in this electric vehicle also. So first, coming to this battery electric vehicle, you can think about like a internal combustion engine, how much is the pollution, and here it is the how much reduction is the pollution is there in. Typically, you can call it like a in your typically in your electric vehicle. Then it is the statistics of the global stock of the 2010 to 2019. that how the number of the battery in millions, like electric car in stock in millions are increasing. I mean, like typically, and of course in India also it start coming. And this is typically the vehicle charger, because you need the vehicle charger structure. I can see, I don't know whether many of you are aware that how we have a really trouble initially of CNG launching in city like Delhi for how the major vehicle are really buses and three-wheelers and taxis on CNG. But many people drive with the CNG because this fuel cost is one-fourth or one-third compared to your petrol. So local, I mean charging, typically the local is run by your CNG only. So here also, even if you have a hybrid vehicle, you will like to run day-to-day life with your battery only. You will not be really running with the either petrol or other kind of fuel. When you are going to highway or long distance, then only probably you might be using this fuel in a hybrid vehicle, typically which you call petrol or diesel or CNG. But for local driving of every day 100 kilometer or so, you'll be driving certainly with the battery. I mean, depends on which kind of hybrid, I mean, configuration of your vehicle is there in a hybrid vehicle also. So, well, you have a typical, I mean, here that what we are expecting, the global EV or your hybrid electric vehicle, I mean, is supposed to go. And this is the regional growth, I mean, how it is going to be of the hybrid vehicle market. I mean, you can just see it. It has been, of course, in India, typically the mild one. We are here in the mild one, like also. But of course, in North America, it has been reasonably high. You can just see the North America completely high, as well as in the typically the part of Europe, as well as part of like a other part of the world is also quite high. And then, of course, the mild reasonably. But of course, we are also in mild phase also. These are the typically some of the, let's say, I mean, the company which are in India, the global statistics about the vehicle. I mean, electric vehicle especially coming up, that even the GM and other, or including the Mahindra and Maruti, they are also planning to have so many model, typically in by 2022 or 2030 in the electric vehicle also. And Nissan, typically Renault, Nissan, Mitsubishi, Tata Motors, Tesla, Toyota. I mean, Tesla also even permitting further models of electric vehicle. So these are typically the statistics, like how, or the announcement, the different industry are manufacturing or going to manufacture this electric vehicle. They have really launched announcement that what they are coming in next few years, like on towards this, like I mean, on. Then this is about the typically the, I mean, different industry which are there. Another is the classification of electric vehicle. I mean, you have a lot of classification of electric vehicle, different type of electric vehicle. Apart from hybrid, you have a complete electric battery charging, and think about like so many kind of scopes varies because you have a lot of motors which you can use it. I mean, electric vehicle, so classification can be on your type of light electric vehicle, light car, passenger car, uh, typically on this, and another based on charging infrastructure. So this is all associated electric ecosystem, how it goes. One is the, I mean, battery, another component is the major component is the motor. There is a revolution in the motor, variety of the motor. There is a revolution in the battery, lot of variety of the battery. There is a lot of variety of the your hybrid kind of, even there is a lot of revolution in the charging infrastructure. I mean, and so much ecosystem is there about the your electric vehicle or hybrid vehicle, like. And this is a classification of the vehicle starting from internal combustion engine, then hybrid vehicle, plug-in hybrid vehicle. I mean, all are defined fuel hybrid vehicle, and then finally, typically maybe or some are there even the, or you can call it like a battery electric vehicle also. So all vehicles are here as far as classification is concerned, where you are going to introduce electrical component into it. Like, I mean, so this was internal combustion engine base. After that, you start bringing the motor, whether it is a hybrid or plug-in hybrid or other kind of classification here. And this is something classical. Of course, you might be knowing much more than me. You have a fuel, then you have engine and transmission. In hybrid, you have many kind of hybrid. I will just try to expose later. So you have a motor generator, that also I was talking about, and fuel also. So initially you might have a 50% torque from there and 50% here. So it means engine capacity can be reduced to 50%. That saves a lot of fuel. I mean, apart from that, the same engine is able to generate, work as a generator. This battery also is able to drive, which really we can use. So it's not connected, you can call it with the grid at all, kind of thing. So entire energy you are coming. But since you have this, you can apply the regenerative braking. So whatever energy recovery benefit we are saying in city driving 40 to 50%, you can get here also. Only this this part is help for starting, so that the motor rating is also not very high. Apart from another benefit you are getting typically of your even a typically of regeneration also in hybrid too. But the major benefit of hybrid that you don't have a mind psychology that okay there is no range limit, like because you have an engine with the fuel, you can run as long as, because this fuel which you are talking petrol, gas or petrol or diesel, you can get probably now anywhere which you are already getting in typically conventional vehicle also. But now we are getting a battery based, this is battery electric vehicle, where you can think about, of course we have to charge the battery and charging infrastructure coming up. But the benefit here, it certainly you can call it like we get the reasonable regeneration also here, and certainly we reduce the mechanical component also here drastically down. Apart from that, the efficiency of this, typically the motor which work as a generator also during regenerative braking, the efficiency you can think about even up to 95, 90 to 95, order of 95% efficiency is not even a very large for this electric motor, like which they are start using now, compared to your internal combustion engines, which might have efficiency around 40 to 45%, not more than that. So efficiency is almost double of this conversion here from your chemical energy of this nature to this nature compared to your this, I mean, chemical fuel, I mean, of petrol or diesel to here. So that makes a great difference why we have to go. So you have a all kind of internal combustion engine, then micro hybrid, and then you have a hybrid of different variety. Then you have a now coming up battery electric vehicle or fuel based electric vehicle also. These are some of the configuration like a series. Series you have a fuel and then you have a typically battery and motor. Okay, you are only having, then you have a parallel, I mean, which I have shown the diagram here, fuel to engine, IC engine, and then another is the battery and motor generator. Of course, you can have a regeneration in all these, and then you have a series parallel, you can have a series also, you can have a parallel also, and then complex hybrid. So the lot of configuration already appear, and many of the industry, these are the some of the hybrid model. I mean, in different company have they put in their vehicle, you can call it micro hybrid or mild hybrid or full hybrid or plug-in hybrid. Plug-in hybrid means you are plugging also to the net and all that, like to your grid network also. So that is typically like you can call it the plug-in hybrid. So you can have a really fuel or you can charge also. I mean the battery. So both provision are there in that, like also in plug-in. And these are of course the comparison. I mean one can go. I can leave the slide and different kind of configuration which you already talk about. Now coming to energy storage, especially your EV or hybrid EV, it's a different kind of energy sources. I mean, typically one is the electrochemical batteries, we call it the battery, and you have ultra capacitor, ultra flywheel, as well as fuel cell. People have tried it, like I mean, so there is a fuel cell also coming up a big way. Apart from that, you have a typically a battery-based electric vehicle, and flywheel also people have tried. I mean, like also in that ultra capacitor also people tried. And well, so ultra capacitor really help during the dynamics transients initially, like I mean, so different I mean storage, and this is virtually how chain of the battery, like you have component production, cell production, module production, pack assembly, vehicle integration use, and then you might have a recycling of the battery, like also. So well, the selection criteria are of course that it is a portable, you have a lightweight. I mean, these are the some of the criteria which on basis we decide the battery, what battery we should take it, like also. And then the energy source typically kind of things. So a lot of concept are there here, like coming down on the basis of which we should select it. Typically the your battery or so. Then coming to drive chain for hybrid vehicle and EV. So drive chain, which I already mentioned it, like typically your hybrid simple. Typically is your energy system, energy source, then power converter motor, and your mechanical transmission. I mean mechanical transmission in the sense you might have a single stage gear. Because many applications, like even I was talking about e-rickshaw, you have a single stage gear, because motor, when you design at high speed, certainly the size of the volume, size, weight as reduces and efficiency increases. So that is even for e-rickshaw also, motor is of 3,300 RPM and you have a single stage gear or so. So then, of course, these are the different elements of mechanical system. I know to talk, you might be knowing much better than that. And well, here, if you have a motor, then the clutch and gearbox and differential. I mean, like then the second one is the only gearbox. So and differential. So some component go on going, and then you might have a typically third configuration of electric vehicle where you have a fixed gear and differential. Then you have a fourth configuration with you have a separate, let's say, motor for two flywheel or all the flywheel, and then you have fixed gear, and then you don't have at all the gear. I mean, like fixed gear is there with the, but it's a wheel drive like kind of thing. So there are, and then the motor, directly wheel drive, there's no gear like, I mean, so there are a lot of configuration of electric vehicle has come, and this is the last journey on which we have like typically a motor directly in the hub motor of the wheel, I mean, like also. So you have a lot of hybrid vehicle like a series, parallel, and series hybrid. I think you'll be exposed during the course by other speaker also. But I was just to give you just idea, and like what is the benefit, like you like to have maximum fuel efficiency, minimum emission, minimum system cost, and good driving range like also. And this is like your series hybrid. So you have fuel tank, engine, generator, then your converter, battery, converter, motor, and mechanical transmission. And of course, you can still have a regeneration here to come to the battery, and you can take a benefit of this battery. And of course, here you prefer that your generator, whenever it's running, it should run at full capacity so that you get a fuel economy zone, and the whatever the energy is going to the motor, remaining energy can go to the battery. So all the benefit of this running as your typically engine with the proper generator, I mean, it can be done in this manner. But the why this side is the motor, because you can get a benefit which we say that you can recover the energy around 40 to 50% during regeneration. That is still can happen in this case like also. So certainly you will see your engine rating will reduce it, as well as the typically the generator rating need not to be that, because some energy for dynamics you can keep in the battery also, along with some energy coming from there, some energy coming from there, and energy can recover here certainly. So that benefit which we are talking about, but the major benefit of this series hybrid, that you don't have a nexity of your that okay, you will not you will have a limit of the range of now, because finally your fuel is the same, your diesel or petrol which you can have here, but you are getting an entire benefit of regeneration as well as reduction of pollution up to some extent because of the brake also. And there is no range range energy in your mind that okay, I will not be able to drive my car for longer distance, like that also goes in that. So these are the some of the of course feature on that. I mean, I will just, then you have a series kind of the another series a kind of hybrid, that is the basic concept, like how the power transmission, and you have a traction motor to entire. Then the another is startup, how it goes, okay, and light load, how it goes. I mean, like that's the concept, like where the energy flows. So during starting, you are getting energy from battery also, as well as from engine, a generator side also. But during light load, of course, you are charging the battery as well as you are driving. So that's virtually the kind of series hybrid. And then operation, how it is during regeneration braking, I call regenerative braking. You are getting energy back into electrical form and charging the battery. No power might be coming from there, or you might be charging the battery from both sides, typically like or so. So that is typically the benefit of this series hybrid also. And then of course these are different operating modes like you can think about. And then we have a like a series hybrid. All these, I mean, I will just skip. I think you can go typically. I will go like a parallel hybrid. These are kind of parallel hybrid in the sense that you have a battery, converter, motor, and then you have a both are coming with the mechanical coupling, and finally on the wheel or so. So in this process, you will be able to reduce the rating of this your engine, because some torque or let's say power is coming during starting also, dynamics also from motor side. But during regeneration, it also can charge the battery. So that regeneration or regenerative braking can be applied in this case also, like I mean also. But you know to certainly charge the battery from your fuel engine. I mean that is something here like I mean also. And you can charge the battery from that also. So this is parallel how it is. The arrangement means the energy from your fuel tank and IC engine, if it is coming to the battery, it is coming from transmission system only during maybe regeneration, otherwise like also. Otherwise, you are running parallel, I mean the both the things are running typically in parallel from both energy also. So that is we call it parallel hybrid also. And how the torque and arrangement are there, like I mean lot of literature is there, lot of books are there. I mean I hope list, I have asked my TA to put the list of the book in my lecture. I think that you can probably think about. And that is again parallel hybrid concept only also. So different concepts are there for parallel. This is another series parallel. Series parallel in the sense you are giving engine also this, and then you are coming from this generator. You have generator, small generator which charges the battery and going to motor. This generator may be certainly quite small because you are getting 50% energy towards the motor and 50 goes there. But you certainly you can have a, you are charging the battery and you can drive the motor continuously. Apart from that, you can have a regeneration. So all those benefits are there, and you are able to reduce, certainly you are able to use the engine more effectively in the sense not only driving here the power, but remaining power can go from engine to this side also for charging the battery from the generator. And that is the configuration. So a lot of configuration of hybrid has come. So this is series parallel. I mean, that how the energy flows into that, like, I mean, so these are the different modes I can just suggest you, and you can go through. I mean, like, these are already material reported in many of the books, like, I mean, say, I can say. Then coming to like a state of art on it. So key technology, the typical engine, battery, then motor drive, all those, and the overview of the battery technology, which I already mentioned. So you have a different kind of battery coming up. In India, we have a lead acid battery more popular, but now you can say, I mean, your lithium-ion battery are coming, the new battery. I mean, like, these are new battery which are coming up, which can charge at very fast rate. I'll just show somewhere the charging pattern is there. You can charge as high as like maybe 25C or 10C. Okay, or 10C is here, you can see 10C means, I mean, if it is a 100 ampere our battery, you can charge from the 1000 ampere. So you can think about in charging probably in 3 minutes, 5-6 minutes only, or even lesser, around maximum around 7 to 8 minutes also. So those technology has come that you can quickly charge. By the time you take the tea, your battery is fully charged on the even on a highway also, like. So that is about the how different batteries, and they have a cost, specific power, safety, and you have to make a balance among all these factors also when selecting the different. Even a lithium-ion battery, you have a lot of variety of the battery. Like, okay, there is a nickel cadmium battery, then sodium battery. So major battery, lot of variety of the battery development have come because there is a need, a lot of battery, not only for this application, but we are going to have like a other applications also where the battery is needed. Like coming to motor technology, you have a lot of variety of the motor, and we expect the motor that you must have a instant power and high power density, typically from the motor, so that the weight of the motor is not so high. You must have a high efficiency also, and high torque at low speed for starting and climbing, and very wide range of constant torque and constant power region, so that it suits characteristic very well, and high efficiency over a wide range and torque, and high efficiency during regenerative braking. I mean, and very robust, like, and reasonable, like. So these are some, of course, the requirement of typically general requirement, and especially additional requirement of high efficiency of power generation over a wide range, good voltage regulation over a wide speed regulation, capable of being integrated with the engine, and in a hybrid kind of and these are the typical electric motors. I mean, earlier we were using the DC motors. I mean, now we are not going to be DC motor because maintenance requirement is there. Out of induction motor, cage induction motor is quite popular, and Tesla already used the squirrel cage induction motor. Because Tesla has invented, they took the name Tesla because Tesla has invented the induction motor. And then you have a synchronous motor of different variety, like, I mean, also, okay. Typically, like, you can think about the permanent, is coming the permanent uh, large rating permanent AC motor, and permanent low rating permanent brushless motor, and synchronous electric motor also coming because it has a higher efficiency than canned induction motor. The last 5-6 years, I mean, some of the industry like ABB, they brought synchronous electric motor of very specific kind. So they have to be ported with the typically operated with the inverter, like, I mean, and of course in vehicle we operate with the inverter. Then you have a cell pole machine, doubly cylinder machine with the even a PM also. So the machine which are going to be now in vehicle, it is all brushless machine, like. And these are the torque characteristic of typically of your, you can call it like your motors, and the requirement of this is the requirement of the vehicle. I mean, during starting you need a large torque, and after that you go to the constant power mode. That is the requirement of your vehicle. And look, your engine torque characteristic and power characteristic is this one. We did not suit the vehicle requirement. This is the vehicle requirement, like, okay. Large torque during starting, after that constant power. As you see, the constant torque means the power is increasing with the speed, and then after that constant power, the torque have to reduce. This is the requirement when vehicle start moving. I mean, but this is your IC engine characteristic, torque speed characteristic, and so what we have to do to make this to suit to electric to your vehicle, we have to put the multi-stage gear. This is the gear. This is the same torque speed characteristic as you see here, but with the help of gear, we have to probably suit this kind of characteristic which we require in the vehicle also. So it means that is the reason why you have to need the gear. But if you take an electric motor, there is no need of gear. I mean, correct. You can control the motor in such a manner that it works very well for meeting the requirement of the vehicle without any much problem, with no mechanical component, only by electrical control of this electric motors also, and how it goes with the or single gear, just to change the speed and to increase the torque. Otherwise, no control on this. I mean, like also with the gear or something. Only single stage gear, no clutch or no change of the gear also. I mean, like, So that's the advantage like coming up. And these are the typical motor. Earlier people use the DC motors, like Riva used DC motor, but finally when we gone to Mahindra, they start using these brushless motors. These are the you can call it brushless motors. Even a cage in the skull cage induction machine, permanent bow, two type of machine, reluctance machine. Even a reluctance machine also manufactured for vehicle by Eddy Current Drive Limited in Kerala. I mean, that is the one of the manufacturer for vehicle. And then synchronous reluctance, this is coming up the machine. So of course DC motor by the many advantage, but the major disadvantage is the commutator and brushes. So it's not. But induction machine, of course, going to be big way with the copper bar, copper die, typically the copper bar, so that you can get high efficiency. And I can tell you, interestingly, like even around the Tesla, which is using 18 to 20 kilowatt motors, the efficiency is around 95%. Like but when you go little higher rating, the efficiency certainly the difference between other special motors and the induction motor is not much different. But this motor is supposed to be very robust, cage induction motor. That's the reason Tesla took it the first impact on the vehicle, that vehicle should be reliable and robust. And apart from that, Tesla has invented the induction motor, so they took the sentiment also of the people, like, okay, we put the name on the inventor of this motor, like, or so. So there are some benefit, like which I already mentioned about induction motor, because we rewarded around 40 years of our life only on induction motor, typically. So there are many examples which induction motor, squirrel cage induction motor used in electric vehicle, like a GM. Okay, this model GEV1, they use the induction motor. Then the Audi also use the induction motor. Then Nissan also use in their model electric motors. And then Hyundai also use induction motor. Then Tesla, they use in Tesla Model 3 induction motor. And they were the first to use the induction motor. Then the Tesla other model, I mean, like these for other purpose, they also use the induction motor. And then Mahindra also use typically the induction motor. Then Ford Thin, they also use the induction motor. Then Ford Ranger also use the induction motor for. And Tesla S also model is also induction motor. So you can think about so many cars already available, or different vehicles are available with induction motor. But you can understand all are using the induction motor with typically the single stage gear. The motor is designed certainly at high speed, like also. And moreover, these all vehicles you have seen four-wheeler, so their motor rating is reasonably large enough. I mean, once you have a motor rating large enough, the efficiency of the induction motor is also quite high. But the other machine which is really making a bench on this permanent brushless machine, I mean, like, and permanent brushless machine with the permanent on the rotor and stator is similar to like your induction motor. So a lot of company now, Nissan Leaf, and you think about like vehicle, they want to accelerate 144 kilometer in 7.9 seconds, like also. Then the Nissan Leaf, another model. I mean, then your typically Chelvet, another model. And then you have another model of Chelvet, and then another model of with the PMSM, permanent synchronous motor. And then typically this is, think about 82 kilowatt motor in this, your permanent synchronous, interior permanent synchronous motor of 82 kilowatt is put in this, your two-wheeler, because you want to fly it like anything, like the teenagers. So they know. And another model of the two-wheeler, another model of the two-wheeler, where we are using interior permanent synchronous motor, like also. And then another model of interior, but these all are reasonably high rating, like or car of interior. And then another car model with this your permanent synchronous motor of 81 kilowatt, like it's not a small rating, or 150 kilowatt, your typically of your permanent synchronous motor, or your Tesla model. Rear wheel, they are using induction motor. Front wheel, they are using PMSM. So they are using mix of both the technology, the best one. And of course, this is another model, Tesla Model S and X. They are using PMSM as well as induction motor. And Kia is using like a permanent synchronous motor of typically. So these are permanent synchronous motor, which are used in high, let's say, rating. But lower rating, we use permanent brushless DC motor, which really like a two-wheeler. I mean, like you can think about, it's a permanent brushless DC motor, another kind of motor with rectangular current or so, or the motor, another two-wheeler. Think about like 215 watt motor only in this. Who drive this? Only the, let's say, Indian women or Indian girls who wear their dresses like sari. They don't want to fly their dupatta or sari, so they don't run more than 25 kilometers per hour. But think about what is the motor capacity, 215 watt, and the less than 1 unit, battery capacity, and drive around 50 to 60 kilometers, less than 1 unit, typically a quarter unit. So you can drive your typically even let's say 3 to 4 rupee probably for 15 days your two-wheeler going to office and coming back. So think about how you can, I mean like, and of course little higher rating also, but all are permanent brushless DC motor. I mean like a 250-watt motor, two-wheeler, 250-watt another two-wheeler, 250-watt another two-wheeler, 250-watt another two-wheeler. Lot of industry are manufacturing like, but some are manufacturing of course little higher rating up to 250-watt another two-wheeler. And then your let's say commercial vehicle of India, which have a motor of rating from 750 watt to like 1.25 kilowatt called e-rickshaw. I mean with the lead acid battery and single charge it runs around 90 kilometer with only 48-volt battery with the 100 ampere hour. You require around 3 to 3.5 unit of electricity, not more than that, to drive into 90 kilometer or so. And another kind of like a three-wheeler with the different, you will find the rating around again not more than less than 750 watt, not more than 1.2 kilowatt, out of different activities. And battery also kind of standard like I mean or something. And typically so many variety of three-wheeler, like you can think of it, people start putting even a lithium ion battery also with the solar roof in this, so that you can have a better driving capacity. Or they have converted to three-wheeler virtually into the you can call it the green cart, I mean like, or school rickshaw, I mean e-rickshaw, where the children go to that. Earlier rickshaw was used, now this e-rickshaw is used for that purpose. Or your garbage carrier, I mean you are collecting carrier like, garbage also. Or ice cream vendors, like I mean they use also this kind of like a rickshaw. Or you use the garbage kind of vegetable soap kind of on it also. So this is like what we use permanent brushless DC motor, which are very efficient. And you can think about in the rating of 1 HP like a 750 watt to 1.2 kilowatt, it can easily offer around 95% efficiency of this kind of motor also. Then we have a reluctance motor. This is very special motor, of course. It suits very well because this has the highest starting torque. Of this motor, typically one of the highest starting torque. It's not very difficult to get 8 times the starting torque with twice only the rated current from this motor. We have a starter rotor, both cell and pole motor, cell and pole here. An Indian company. So specifically it suits for vehicle requirement. There is slight noise, but you are not sitting very close to the motor like virtually in that. So there are some advantage and benefit, but it worked very well. An Indian company, I told you, Eddy Current Drive Limited, self manufacturing this for electric vehicle also. Another reluctance machine which is coming up, a big way. And ABB, I think in last 7 years, 8 years, last decade, they manufacture it with no rotor bar or something like that because it's driven by the inverter. And this is one of the motor give a better efficiency than induction motor or a wide speed range also. And there also people are start using this kind of motor. This is the efficiency contour in torque speed characteristic of different brushless motors. And DC motor of course are there, but we are not using. It's just like a benchmark. All other motors are your brushless motor, which are extensively used in the vehicle industry now also. And that is about, I was just already telling about. And these are some example of electric vehicle like Nissan. But think about, you want to accelerate in 7.9 seconds up to speed of 144 kilometers. Like what best you like to fly it? Like Hyundai model, again 7.6 seconds, 165. Then 7. Tesla Model 3. 7.9 seconds you want to fly it 233 kilometers per hour. And you use only how much? Around 15.6 unit into 100 kilometers. But think about when you'll be getting electricity on 2 rupee, so you'll be able to run probably 30 to 35 rupee 100 kilometer from this. And day is not very far, probably further electricity cost can go down also. And you are able to go 475 kilometer on single charge. What else you need? I don't think you will be able to drive the car more than that long distance also. So another auto model. And so many models are there of the four-wheeler. Tesla, another model which I was talking. Look, 250 kilometer per hour speed you want to attain 3.2 seconds kind of thing. So what better than, because torque is so high, you can think about typically 931 Newton meter torque by this motor. And capacity is only for driving for 100 only 100 kilowatt hours the battery capacity or so. So there are plenty of model of this four-wheeler car by worldwide manufacturer, and Tesla one of the leaders. In that. And 6.2 seconds you want to go 200 kilometer per hour or so. And typically Hyundai, Renault, Kia. So a lot of model of the cars are available. Typically from worldwide market, and Indian manufacturer also coming up also. And of course, that is about the vehicle. Now we are coming to the charger. Charger is also very, very important. So you have a charger, we divide into three categories. One is you have a onboard charger, then off-board charger, and then we have a charging infrastructure. You have like a typically as a structure of multi-purpose. These are some standard like by international European standard like AC level 1, AC level 2, AC charging. That is the power rating, that is the maximum current, and that is the charging time. And this is DC fast charging. Power rating may be up to 200 kilowatt with 400 ampere, and you can charge probably less than 1 hour. Even a 0.2 hour also you can charge the typically. And these are American standard, not only AC level 1, 2, but you have a DC 3 level, and you can go even up to 240 kilowatt here with a 400 ampere, and again you can charge again 0.2 hours. Like I mean, think about like a typically maybe 12 minutes, 10 to 12 minutes you can charge your battery. And then it is a Japanese, which is a DC fast charging. You can charge 1 to 2 hours. Like these are some of the standard. And you have an onboard charger which are on the vehicle. They are of small rating even for four-wheeler, like starting 3.3 kilowatt to go to 6.6 kilowatt. And then you have an off-board charging, like a typically like a maybe like a truck charging, bus charging, of starting from 20 kilowatt to going to 50 kilowatt or 80 kilowatt order of that. So these are onboard, offboard. Onboard means on the vehicle itself, you have a charger of small rating, and your fast charger, they are offboard like a petrol pump. You are just keeping this charger. I will show you some of the typical photograph also, all of them, like I mean how it is. So these are typical AC charging one standard. Okay, what is there? Typically the voltage and power and current, and for estimated time also typically. And then these are AC level 2. I mean, we were talking about like a starting typically different rating, like different times from 19.2 kilowatt, 7 kilowatt, 20 kilowatt, and the time also given that in 22 minutes or 3 hours up to 7 hours or so. And then AC level 3 means further higher power, 20 kilowatt or so, single phase, three phase. Then DC level 1 and DC level 2. So all specifications, these are the standard, different standard, virtually European and American standard as well as Japanese standard. And of course, we are also adopting at the moment same kind of standard. Like there's no point of developing a separate standard when you have a well-established standard throughout worldwide. Like also, well, these are connectors typically for the charger, and female connector, male connectors. This is already on typically on your, let's say, your supply side, and this is on your vehicle side. And a lot of kind of with the different kind of standard, you have a lot of kind of charger, typically connector, because connector here current goes very high. So you have to be very careful that no electrical part is really remain, and you have a very good contact between, so that you don't have a kind of a sparking or loose contact or heating kind of thing. And life is also not getting affected. They are very quite good kind of connectors are made for that purpose, of different variety, like hybrid connectors. Then you have a hybrid 2 connectors. You can think about like a petrol pump, how you put in similar kind of shape of the connector, because people like similar kind of configuration, like of different up to 200 ampere order of that. Then less than 20, how did the connector look like, and variety of connector, I mean between different type of connectors coming up, like I mean with the fast charging, DC fast charging, which is certainly 100 even up to 125 ampere, very standard chargers and type of connectors. And these are with the AC charging, vehicle with the AC charging of different companies or industry, and like other model. And then you have a DC fast charging, combo charging or fast charging, the different vehicles from different industries, like I mean also. So all the industry are manufacturing all kind of, and Tesla fast, super fast charger of their car model. You can see how luxury cars and how different kind of car Tesla have developed it. Caution the issue, people are crazy in California to buy these cars, like I mean also. So even a higher cost, but they want kind of luxury car even with this Tesla, but car should be reliable. So coming to the charging system, you have a type of charger, AC DC, or you have a accommodating the charger, whether it is on board in the vehicle itself or off board or wireless charging, will come wireless also, or physical contact conductive fast, like these are. And with the contactless means wire power transfer, or directional power flow, whether unidirectional, you are just charging the battery, or bidirectional, or you are discharging the battery to the vehicle, to the grid also. That G2V, V2G concept for a smart grid. So all those concepts are there in EV charging system. And this is typically the wireless charging, that you are not making physical contact, and that is getting power, that is onboard charger, and that is the typically fast charger kind of concept, like. And this is virtually onboard charger, because entire charger other than supply is in your vehicle, and here it is on offboard charger. So only the vehicle connectors is here. That's all. I mean remain on the charging station, like. So this is onboard charger. You just put charger inside of it. Only power connection is made there on in onboard charger. And of course, there is a need because weight have to be less and small rating are there. But in many car, you have this onboard charger, small rating, and you have a fast DC charger also. You can charge very fast rate while you are driving on highway or otherwise, like also. So both charger are there, and the different technology are there into that conductive, wireless, or typically. And lot of like onboard charger, how many manufacturers are manufacturing with different power rating, like a 3.7 kilowatt, 7.2, 122 kilowatt by these industry, whether single phase or three phase, and these are battery voltage, and this is the power capacity. And then so many you can think about like a onboard charger, but are not very high power rating. I mean 3.7 kilowatt or 7.2 kilowatt, either fed normally from single phase. Some cases is only three phase, like Tesla have a three phase onboard charger also. I mean, but all the industry have their like a BMW, but their rating is not quite high, like more than 7.7 or typically. So that is onboard charger. A lot of industry are manufacturing. This is offboard charger. That like in a charging station or in your home, you are just putting a station and you put your car. The entire weight goes no here. In vehicle, we don't have a big charger. Only you have to putting a connector virtually to the battery directly, and it coordinate with the battery through power communication protocol also. So these are the benefit that weight is removed, and other benefit is also there. Heating is also not there. I mean, like, and you have a fast charging also, you can have it, and efficient charging. And these are some of the cases, like typically you can think about like highway, you have fast charging in up to half an hour, then commercial half an hour to 2 hour, then the office ACDC. I mean, you can have up to half an hour to 8 hours, or you have a home typically 8 hour or 2 hours, like kind of the charging. These are the very standard charging. We have one in our campus also for R&D, and of 50 kilowatt with the test Delta, and 125 and 50 volt to 500 volt. So you can charge the even e-rickshaw or your car of wide voltage range from this, and 95% efficiency, good efficiency. And this is not the model by one company. You will find so many company, Elefon, then Tritium, same rating. I mean, they have a common standard kind of things. And then ABB, I mean, so a lot of manufacturer have come in this rating, 50 kilowatt and 125 ampere DC, as well as 50 to this, like, I mean, also, of course, such 50 kilowatt certainly had to be three-phase supply only, 50 kilowatt, 125. And so a lot of manufacturer have come in the same standard rating of the power, DC current, and voltage also, output voltage, so that you can charge, and same communication protocol also, so that they are compatible from one vehicle to another vehicle also. So a lot of, I mean, like typically a lot of manufacturer in this, except one or two Tesla supercharger of 250 kilowatt with the fast and output voltage up to that. Again, otherwise another Orca model also 50 kilowatt, 125. So a lot of Orbitec power, or typically these are only, of course, Valve kind of lower power. Otherwise, all were 50 kilowatt, 125 ampere, 50 watt. And these are the extreme fast charging. On normally on the highway, you can charge in very short rate. How much is small? Like a 7 minute, but 750 kilowatt it has, and starting from 2 hour for 20 kilowatt to slowly going to this fast charging. And type of typically the standard for how did the standard for these all chargers, like connectors, details, power rating for 400 kilowatt. You can think about up to maximum voltage of 1 kV as well as 400 ampere. So how much fast it will be. And there is another concept for charging infrastructure where you have a AC bus. You are allowed to take power from the grid. You are taking power from the PV. You are taking power from energy storage like a battery, and you are charging here, typically with the separate charger, like you can call it off-board charger. I mean, this is charging station, you can call it. It takes energy from PV also, and if you are not having vehicle, you can put the power of from PV to grid also, and you can take power from the grid also along with this, also as well as the battery. And this is the DC bus base charging station. Okay, charging infrastructure. So you are taking from PV also, you are interacting with the battery bidirectional, and then you have vehicle, and you can take bidirectional power to the grid, because PV energy more than you can put to the grid also. Like depends how much it is typically PV generation. So you have a lot of like a DC fast charging of different power rating, like starting from 16 ampere to 400 ampere. And the different modules also, and modular concept also, that you can connect the different modules for increasing the rating of charger, or you have express up to 400 kilowatt. I mean, and this is 35 kilowatt by Tesla supercharger, how fast you can charge this. And a lot of industry have come this fast charging kind of the supercharger, DC fast supercharger also of similar standard, like, I mean, express. Then we have a concept which have wireless power transfer charging. You are not making physical contact like between the vehicle and your typically of the charger. Like, so initially in 19th century, 1888, Tesla did for wireless power transfer experiment. and that was his setup. And typically other people also done it between. This was 19. Typically he did laboratory one, and like a radio wireless transfer. So a lot of work on wireless transfer during the different time. And you can say in typically 2007, after 125 years, MIT did repeat the experiment of Tesla. I mean, for this wireless power transfer, this is a setup for that, and the team who did this work. And after 4 years, 2007 to 2011, Nissan brought a wireless power transfer charger, commercial charger after 4 years. So how technology developed, how far, and now so many company have come with the wireless charging like Qualcomm, Dell P, and Kiest also. And why you need the typically because you have a heavy connector, heavy chalk, and other thing. Look, you can have it, but think about here. If you put the connector, you cannot take out, and because of snow, you cannot put. So there is a requirement of wireless power transfer, and like a static wireless or you have a dynamic wireless on the charging get from your lane also. Even a kiosk in Korea, typically South Korea as well as America, they develop many routes of that kind of. And this is the basic concept of it. You have a light charger also here, and this is the supply with the power factor correction, and you have a like a here that up to 2 feet space you can have, and these are the capacitor which compensate for both to not to allow the DC in the transformer. Apart from that, compensate for reactive power, and then you have a charging on the battery. Like, but you have a small rating of board onboard charge also along with the wireless. Like, and these are the so many company are commercially making this wireless charger like in such a high frequency so that transformer size is reduced, and it's 600 millimeter means 61 centimeter 2 feet distance you can have between that. And this is a power rating, it has gone up to 180 kilowatt charger in wireless with the good efficiency, and 85 kilohertz is the another one, 200, then 162 millimeter. I mean, you'll find the different distance and different data by so many company, like virtually not one or two has come in wireless power transfer charger like then the integration of renewable. I mean, people have come the charging from the renewable like a solar, another shape of solar, wind and solar in charging infrastructure like a wind solar of different variety. I mean, like also and different concept of in this renewable generation into it, and then how it is the charging ecosystem is based on the renewable because it is going to be cheaper day and night, and coming up with the typically renewable with the big way on the rooftop. You can have your vehicle charge on or your parking on the or you are using like typically and this is typically you are going to be like a role of electric vehicle in a smart grid. I mean, like a smart grid is playing big way. I told you that you can have a vehicle to grid or grid to vehicle also. I mean, when you have a cheap electricity, you charge the vehicle battery from the grid, and when it is costly, then you can put back the energy. So both way you can have with the smart grid concept. It's coming up, and it's a G to grid to vehicle and or vehicle to grid. You can have here without any much problem. That is vehicle to grid. That you can put the power from your vehicle battery to grid when it is a costly electricity. So all those aspects you can have, or vehicle your home to vehicle, which normally you have a charger, but you can have a vehicle to home also. You can even run the vehicle your home appliances also from the vehicle battery also. So vehicle to typically the grid also. So all those aspects are there, and it has come V2X, where X is your grid or load or home or vehicle to vehicle. So that is a smart charging concept has come in the typically last. I mean, it's really helping to the grid, which is making a smart grid, this electric vehicle technology with the smart putting concept here. And this is the virtually how it is the stabilizing the grid, and all aspect are there with the this kind of charger here, vehicle to grid, vehicle to load, vehicle to home, and vehicle to vehicle. All kind of concept are there in this charging infrastructure concept. Like, and coming to like a growth of Indian electric market, I told you like we have a two-wheeler scope which is given by can be two-wheeler, three-wheeler up to 81% and 13% of different segment how it is going. And Government of India put different launch starting from 2010 to 2020 FAME 2 is coming up, and how the vehicle is going to be and what is the business model is going to become by even the government is putting subsidy of 3.4 billion Indian rupee for the subsidy for all different kind of the vehicle, and launching of different technology or different concept in different and these are the lot of manufacture in India of this your typically of the vehicle here, as well as coming to hybrid or other different kind of electric vehicle, transition in automobile sector in India from these all. And these are the typically Leonarthon battery landscape in India by this industry coming to 2 gigawatt hour install capacity. And then different company are supposed to have a charging market with the different industry are coming. Indian industry are also coming up in charging infrastructure also. And then this is the first charging station are put typically in India. And then ABB have launched same charger, 50 kilowatt, 50 to 50, 500 and 125 ampere with the standard charger I showed you. A lot of company are making that is that ABB put in even in Niti Aayog also. And a lot of like in Jabalpur, a lot of four-wheeler chargers and already they start putting. And typically by another charger typically put in Mumbai. And then of course this charger by typically in put in Tata Power in Mumbai, then in Nagpur, and then by NTPC. And then, of course, in our campus also, we have one vehicle and one Delta charger for the purpose of research. And these are the different Indian manufacturer of this vehicle, two-wheelers, which we are expecting that Hero Electric, so many model. And then you have a Okinawa, different model of two-wheelers, typically by Ather two-wheelers, Ampere vehicle two-wheelers, Revolt bike, Mahindra bike two-wheeler, Platino, Komaki two-wheeler, then Evolved, Green Kovacs model, then Yamaha, bicycle, e-tron. So these you can think about two-wheeler, how big market is coming up in India also. And then three-wheelers. So I told you like a three-wheeler e-rickshaw, how big it's coming by Mahindra and other manufacturer, probably might be more than 100 manufacturer in India on for e-rickshaw of different capacity. All the data are here by Kinetic, okay, different models, then Volta Motors, Atom Motors, and you can just see how it look like typically varying of this e-rickshaw, the charger kind of. And now people start putting a solar on the rooftop of it, starting from 350 watt to 650 watt, which really increases the range by 50% for all these on putting you can call it the solar on the the top of this. Well, it's not a concept of beauty. Vehicle does not run very fast speed, so there is no damage to but it increases the range by 50% or so, which really increase the wages of the person who is driving by 50% or so. And this is typically like a by Shastri Group three-wheeler for different purpose, which I already shown the photograph and how the ecosystem coming. And now people start putting in lithium also, which increases the range with the solar also, further range to 120 kilometer per charge with the solar. And these are the different solar addition into that solar assist coming up to increase the range also. Then the four-wheeler on Indian roads. Typically a lot of four-wheelers like coming up in Indian market also, like how they are going to plan tomorrow also, like a Mahindra, Toyota, Mitsubishi, Honda. These are the coming for Indian market also, like now typically of different and what is the plan by different company like us. Some of the Indian companies and they are coming. And there are of course many standard IEC, I told you, then the BSA standard, then your worldwide standard of different varieties on this vehicle or IEC standard. Like also, of course, these are some of the typically the references. So with this, I will like to thank. And if you have any specific question, I will be happy to answer. Back to you. Okay. Yes, I am not too late, I think, or I am not finished too early also. Yes. If any question is there, I will be happy to answer. Okay.
Yes, sir.
So,
Sir,
sure.
Chat box. I would like to read it out. So the very first question is from HOD, Dr. C.R. Rajashekar. The question is related to if components are reducing, like for the conversion from IC engine to electric vehicles, but still the cost is high.
Okay. The cost goes with the mass production. Okay, down. I will give you an example. Probably in India, look at cost. Around, if you talk about 5 years back, the e-rickshaw motor controller was 12,500 rupees. But you know how much is the cost today? 6,500 rupees for e-rickshaw, 1.2 kilowatt motor with the controller. So it depends on how you go to mass production. So you'll find in the time to come, cost will go down drastically down. Okay.
Okay, sir.
Okay.
So one more question from my side.
Yes, go ahead.
If there is a fast charging technology which reduces the charging time, so will it impact on battery life?
Very interesting question, I can tell you. We have a lot of apprehension in life, na? Because if we eat meal, such kind of meal, then our stomach will be spoiled. We have a no, my dear. One of the guys suddenly enter in my office in the month of April. I was scared. I told her, I cannot meet you. No, sir, I want to positively meet. I came from California. I am work in Tesla, so I want to talk to you. Okay. So I sat with him half an hour, and he said he want to have some company or startup in India. Okay. And typically on three-wheeler like a rickshaw. Now, what do you want to do it? Well, he might have seen some of our research paper. We start working in charging last 4 to 5 years. So I have guided 3 PhD students. 2 have already finished. Virtually 2 are supposed to finish. I mean, 3 are submitted. The 4th is going to submit. I mean, so one is supposed to be on drive chain, another is a e-rickshaw charger, another is typically like a charging infrastructure kind of things, and another industry person already completed like a charger from two-wheeler to e-bus, like, okay. So around 4 students are completing, like. So he told me like he want to start with, and now last month he called me from California around this time only. I told it may be midnight for you, and sir, but I want to talk to you. I want to know about your student that who finished the PhD, and I want to really thinking higher to her. And I have done the experiment that we can charge even the lead acid battery also at very fast rate. I mean, so he did the experiment that there is no going to harm the battery, even a lead acid battery, for charging at very fast rate. Because we have a perception in mind, something will happen, like, okay. So people agreed the lithium ion, but he says, I have already done the experiment, I want to do practice. Are you having some practical e-rickshaw, actual e-rickshaw? So I want to test my idea on actual e-rickshaw for fast charging. So people have come like look into that. Okay, even a lead acid battery which are very cheap, like 25,000 rupees, only of 100 ampere hour, 48 volt, which are used in e-rickshaw. Can you charge at very fast rate, maybe in 1 hour? If it is not going to harm and it is working all right, why not to go to the technology? Because by the time the e-rickshaw driver is taking the meal, again it can be charged and he can run another shift and earn the double the wages. What is earning 500 to 600 rupees, he can run probably 1,000 to 1,200 rupees in a day. And if he is able to run 3 shifts, these are Indian property, na? You give more money, they can do more work. So guy will be able to, I mean, the person will be able to run the e-rickshaw for 15 hours, and if he is able to earn the 1,500 rupees or 2,000 rupees in a day. So what I mean, these are the kind of technology. Initially, people thought it will be lithium-ion battery only in that, which can be charged at faster rate. But now even people are coming, why not to lead acid battery? And he did the experiment. He wanted practically to do in practice, like whether we can do or not. I told, like, at the moment still we have a corona epidemic, but my student is still back. She was gone to PDF, but she had to come back because of corona. Her family was very scared. And she is here, you can talk. So I gave the number to him. He really get in touch, like, I mean, because he feels that at least some person is at least so much aware that what is this charger is and how can charge and how the power quality issues also can be taken up, like, also. So this is not going to typically, like, you can see it, even like a car, you drive or not, every 4 years you have to change the tire. Are you able to follow?
Yes.
So you use the battery or don't use the battery, certainly you have to replace the battery after 4 years. Are you able to follow?
Yes,
So
sir,
these
yes.
are the kind of component, I mean, you can use or you don't use it. Life is fixed, almost, like, okay. So I don't think it is really the fear that, okay, battery really, I mean, life will be affected or something. No, it is the technology day by day improving in this, na? Because there is a heavy requirement of worldwide.
Yes.
It's not like a vehicle industry require battery. I mean, you can think about like a probably around 5 lakh telecom tower. Okay.
Yes.
And all the microgrid also we need it. Every domestic inverter, every UPS, they have a battery, na? So requirement is so huge. I mean, might be going like probably in millions. So battery technology have to come up throughout the world. And it was expected the cost of the battery in next 2 years will reduce to 1/10. I mean, there have been some seminar we have in our IIT, even this Niti Aayog people also comes into that, and they get the information from different corners of the world, and they coordinate, and they were mentioning that how the fast the battery technology have to build up, because it has become the bottleneck from last 120 or 140 years. So now people are doing research on, and that is the reason you will find all IITs and all NIT have started the material engineering department now. Are you able to follow? I mean, material engineering. However, we are not too good in the research in the science. We are good in the technology up to some extent, implementing the technology, but not too much in science. Like, so, I mean, it's not like a battery life will be affected or something like that. Like, okay, I hope you might be
Yes, sir.
partially satisfied by my answer.
Yes, sir. Yes, sir.
Okay.
Definitely.
So any other question if you have?
Yes, sir. I request participants to post the doubts in the chat box.
Otherwise, you can
Well,
send by email also, no? No problem.
yes, sir.
Hmm.
So few participants are requesting the PPT.
Ah, no
Like,
problem. No problem.
yes, sir.
We share it. Okay, PDF. I will ask my student to send by PDF. Okay.
Yes, sir. Yes, sir.
हाँ तो यार who
Yes,
is
sir.
in touch
Thank
with
you,
your
sir.
help the government. Okay. So can I
Yes,
leave?
sir. Yes, sir. Thank you for your informative
Okay.
session
Okay. No
about the
problem.
overview of it, sir. Thank you so
Okay.
much.
Thank.
I request participants to fill this feedback and attendance link, which is posted in the chat box immediately. The next session will be at 11:30. Okay, you can take a break for 10 minutes. The link will remain the same for the next session also.